Welcome! In this series of short videos, we will look at topics for the PowerBasic console compiler. Today we will look at measuring performance using the console compiler's fix command. Today we're going to be starting a brand new application. The focus on this application is measuring performance in your console compiler apps. However, as we did in the previous application, we're going to put a few standard parts of code into our application to create a log and to append to it when the application starts and ends. So in our PB main function, we've added a few lines of code. We have three variables at the beginning of the PB main function. A log variable to hold the path and name of our log, an error variable to hold any error message the code is going to return, and a result variable to hold a string of our report result. So first we're populating the log variable, using xaname$ to pull back the name of our application, and then appending to the end of that an underline and the word log.txt. The first task within this function is to wipe this log if it currently exists. We're doing this within a try-catch block. This way, if the log does not appear, it will not generate any visible error. Next, we're going to use our append to a file function to add a message to our log to say that the application has now started. This will print to our console write to log successful if we successfully manage to append to the file. If the file does not exist, then the file will be created. And should any error occur during the creation of this file, then the error message will be added to our error variable. Our next task is to make a call to a new function called process, and this process function will be doing all the processing. After that function returns, it will return either a true or a false. If it returns true, our processing has been successful. If it returns false, then our processing will be unsuccessful. And at that point, we will print out the value of our result variable. We will call exitApp, which will wait 3 seconds, and then we will append to our log to say our application has now completed. So let's now go and create our process function. And here is the skeleton of our new function taking its single parameter, which is the name and the path to our log file. We're creating 4 local variables here. We're going to be using a for next loop. So our count variable is going to be the counter for that loop. We're going to be using the ticks command in this function. And the ticks command is a very useful command in PowerBasic when you need to keep a very fine view of what your performance in a function actually is. So we're going to set this timer variable up as a quad variable. And again, we have an error variable and a title for our log message. So before we go further, we're going to create a constant at the beginning of our application. And this constant is max loop. We're going to be using a for next loop in our process function. And this constant is going to set the maximum number of iterations of this loop. So we're now going to compare a number of different ways of processing. And we're going to use the ticks command, that's TIX, to keep track of how long each one of these attempts actually takes in clock cycles. So here is our first attempt at a for next loop. We're setting our title variable to the words no sleep. We're then using the ticks command to start our clock cycle count. The ticks command takes a single parameter when starting our clock, and that is the name of the variable we're going to be using. This variable has to be a quad variable. Next, we're doing a for next loop, going from 1 to the value in max loop, which currently is 100. Between the for and the next, we have no code at all. So the application will merely be counting from 1 to 100. And then after that, we're using the ticks_n command. The ticks_n command will stop the clock, and the value left in the timer variable will be the number of clock cycles that have been used. In order to determine how long this is, we'll need to print this out to our log. As we're going to be doing a number of printing details out to our log, I'm going to be using a macro here to save a little bit of typing and to make the code look a little cleaner. So here is the call to our macro, taking 3 parameters: the log, the title, and any error. The error will be an output variable from this macro. So let's now go and create the macro before we run our application. And here is our macro. If you haven't used macros before, they are a very powerful construct in PowerBasic. In our macro, you'll see we have the name of the macro itself. I tend to precede macro names with the letter M, if only to indicate to myself later that this is indeed a macro. And you'll see in brackets we have the name of 3 variables. Unlike calling a function, these variables do not need to be declared as strings, numbers, or whatever. This is because when our application compiles, the line mlog message is replaced entirely by the content of this macro. And this macro has a single line. This is append to a file. Of course, your macro could contain multiple lines of code. So it's a very easy way of saving some typing and making your code look much cleaner. Before we run our application, we will mark our function as true to indicate to the calling pbmain function that it has been successful. And if we run the application now, we'll see the processing's been successful and the application has completed. So if we have a look now in the folder to see what has gone into our log file. And here is our log file, demo2 log. If we open that up, we will see our app started at 10:46 and 24 seconds and finished 3 seconds later. As we have a 3-second delay at the end of our application, this is where the 3 seconds went. And for our call to this function, our processing took 273 clock cycles, which is a very short amount of time. So now we have our baseline for a straightforward for next loop. So let's now go and do a second iteration. And here we have another iteration of our for next loop. And our text message in here is for a 1 millisecond sleep. We are starting our timer as before. We're doing our for next loop. And within the for next loop, we are doing a sleep for 1 millisecond to emulate some processing. And in addition to that, we are printing out to our console the counter, which will run from 1 to 100. And as before, we're calling our macro once more to print the details out to our log. So let's try running that one. We can see a message going out to our log for each of the iterations, and the application ends. So let's now once more have a look at our log to see what changed to the amount of clock cycles we have. And there we have our second line of processing. Now the first line of processing is taking more clock cycles than it did the last time. This is something you need to be wary of because your Windows computer is obviously not just running your application. It's doing many other things at the same time. Therefore, if you want to get truly accurate values, you may have to run your test multiple times and then take the average. So as you can see, a 1 millisecond sleep plus printing to the console is taking up a larger number of clock cycles. In this case, 6,000 million. And our app is now up to around 4 seconds in runtime. But even this tiny amount of processing is showing a big difference in clock cycles. So let's get back to the code. So we now have another iteration of our loop. However, this time, although we're still doing the same for next loop, we're only waiting for 1 millisecond, and there is no print command to print to the console. So if we run our application once more, it will run, and our application completes. So let's have a look at the log to see what difference that made. And there we can see a small reduction in processing. We've moved from 6,045 million to 6,038 million. So let's try the iteration once more, but this time only with the print to the console. And here we have our iteration once more, but this time within the for next loop, we only have the print command. So let's run this once more. And again completed. So let's have a look at our log. And there we can see for printing only, we're getting 271 million clock cycles. So obviously this particular iteration is more efficient than the previous one. One of the things to watch for in your applications is doing a lot of printing to the console. Many of your console applications will be set up to run in the background. There will be no one watching them. While printing to the console is useful while you're debugging and testing your application, it's of no functional use when the application is running unattended. But you may still wish to write to a log of some description. But ideally, you want to limit the amount of these calls. So what we're going to do next is a limited print run. It's still going to do the same for next loop, and it's still going to print to the console. But we're going to use the mod command in a way to limit how often we do this print. We know that our loop is between 1 and 100. So what we're doing in this command here is we're taking the count, we're using the mod command with the value 10. So we're basically dividing count by 10, and if the remainder equals 0, then we print to our console. This means it will only print once in every 10 iterations. This technique is very useful because it still gives you information to the log should someone be watching the application, but it limits the number of times you write. If you're processing 100,000 records, then there's no point printing 100,000 lines to the console, as this will take up the majority of the clock cycles. So let's run this now to see if this run takes a smaller number of clock cycles. And there is our application running, and you can see at the end we're printing out only every 10th iteration of our for next loop. If we have a look at the log, we will see that there is the number of clock cycles taken when you're printing for every iteration, and here is the value for limited printing, only 1 in every 10. As you can guess, it's 10% of the number of clock cycles it was for the previous run. So in summary, what we've done today is we've used the ticks command to measure the number of clock cycles used between the ticks beginning and the ticks end. This can be used when you're checking your application to see what's taking the greatest amount of time. You can run it before lines of code or before you call a particular function. Obviously, when your application goes into production mode, you don't want these ticks commands running in your application, as they would be unnecessary. But during development and debugging, it's ideal to check to see if you're doing things the most efficient way possible. There will be times when you write applications that you need really performant code. And this is your way of checking to see if what you're coding now is as performant as it should be. Hopefully you'll find these techniques useful in your own applications, but that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.